Well, this is part two, the no calculator section of the test, the quest last week. And if you have already looked at the portal and you've gotten your grades, you'd see two grades for the quest. See, out of, out of 65 points, there were 13 problems, each worth 5 points on the calculator section. And I don't remember the averages for those for that section of the test, but the averages were much higher. I do know that. The overall grades were much higher in the first part. Many students are still having issues not only with graphing some of these functions, but as I'll explain here, problems 14 through 16, there are still issues with concepts. And so let's go ahead and get started. Over on the right-hand side again, these are the same exact problems that you saw on Thursday or Friday, as long as you are in period 1 or 6. And then if you were in period 2, then basically you got the same questions, but the numbers were just a little bit different. So the graphs and the solutions on the left-hand side over here are going to be just a little bit different as far as numbers go and shape of the graph than what you saw on Friday. So try to apply what you're learning, and if you are in period 2, then here you have a whole fresh new set of problems that you can try on your own. So anyway, you can print out this part of this version of the quest and try these problems as well after you maybe go through the video explanation. So let's start with problem 14. You're being asked for what numbers x, so what real numbers in between negative 2 pi and 2 pi, in which the tangent of x, y equals the tangent of x, has a vertical asymptote. Alright, and so I drew a little unit circle over here just to get a visual, and the visual should help us remember where the tangent does not exist. So the connection here between the question and the concept would be where you have vertical asymptotes on the tangent, that is where the tangent does not exist. Okay? So all you have to do is come up with the angle measures in which the tangent does not exist. Okay? And so I started off by indicating here where the tangent is equal to 0. Okay? Well, the tangent of x is equal to 0 when the numerator of the tangent function, meaning the tangent is equal to the sine of x over the cosine of x. So we have a numerator and we have a denominator. Where the numerator is equal to 0 is where the sine of x is equal to 0. Well, we know when the sine of x is equal to 0, the sine of x is equal to 0 where you have a point on the unit circle in which the y-coordinate is equal to 0. There's all kinds of different ways to remember when the sine of x is equal to 0. Okay, well, I made a little mark here right there at the 0 radian measure and the pi radian measure. So at the right side, if you're on the unit circle, where the x-axis hits the unit circle, that's the point in which the y-coordinate, or the sine of x, is equal to 0. So if you just start at 0 radians and make your way around the unit circle going counterclockwise, starting here at 0, the sine of x is 0 there. And the sine of x is 0 here at the pi radian mark. You can go all the way around to 2 pi radians. Alright, well, that doesn't tell us where we're going to have vertical asymptotes. That's going to tell us where the tangent is 0. In other words, that's going to give us where we have x-intercepts. So if you put any of these values for your answer, then you were giving the x-intercepts and not vertical asymptotes. So let's continue. The vertical asymptotes occur, however, where the cosine of x is equal to 0. In other words, the tangent, meaning the sine over the cosine, the vertical asymptotes are going to occur where the denominator of this function, or of this fraction, you could say it like that, is equal to 0. Well, where around the unit circle is the cosine equal to 0? Well, you know that. The cosine is equal to 0 up at the top and down at the bottom. Up at the top, one angle measure that we can call that is pi over 2. But let's go back to the original question. From negative 2 pi all the way to 2 pi, where would we have vertical asymptotes? Well, let's start at negative 2 pi. If we start here at 0 and we go backwards 2 pi, that right there is negative 2 pi. Then if we go this way, we're going back negative 3 pi over 2. Okay, so that angle measure, when you go back around to here, so you start at 0 and you go backwards, that's negative angles. When you go clockwise, negative 3 pi over 2 takes you right there. So that's 1. Okay, and then we make our way all the way over to this angle here, and what is that angle? Well, there's many different names for that angle, but if we're within negative 2 pi to 2 pi, then from 0, go clockwise 90 degrees. That's clockwise pi over 2 radians, but the angle measure is negative pi over 2 radians. So then we keep going around and we go to pi over 2 radians, and then 3 pi over 2 radians. So we are within our range of negative 2 pi to 2 pi. There are 4 times in which the cosine of x is equal to 0. And they are these 4 angles. Negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. There's many different ways to think about this, but if you're having trouble with this problem, it's because you still are having trouble with your unit circle and with finding radian measures around the unit circle. So that's where your problem lies. You need to practice and understand the unit circle. So that's the answer for 14. 15, most of you got that. Number 15 says, what's the y-intercept of the cosine of x? I'm sorry, cotangent of x. All you had to do was plug in 0 for x. The cotangent of 0 is the cosine of 0 over the sine of 0. Cosine of 0 being 1, sine of 0 being 0. 1 divided by 0 does not exist. So we don't have a y-intercept for the cotangent. The number crosses the y-axis. So that does not exist. More of you got number 15 right than any of these other ones on this page, I think. But 14 and 16 were the ones that you guys, some of you just didn't know how to do. Anyway, number 16, basically the same explanation for 16 as I just gave you for 14. So if you want to know what the explanation is for 16, rewind and to the explanation for 14 and you'll get the answer there. The sine of x is equal to 0 at these 5 real numbers, or these 5 radian measures, however you want to think about it. Okay, and the question was, when does the graph of y equals cosecant of x have a vertical asymptote? Well, cosecant of x has a vertical asymptote where 1 over the sine of x does not exist. In other words, where the sine of x is equal to 0. Okay, so let's move on to the graphs. Number 17, I was blown away at what I saw on number 17. Number 17, you can see the question over here. Y equals 3 times the tangent of 1/4 x. First thing, find the period. The period is pi divided by 1/4. And I did the little work down here. Pi over 1 divided by 1 over 4. Pi divided by 1/4 is pi times 4, which is 4 pi. Well, if 4 pi is the period, then it better take you 4 pi radians to get from one vertical asymptote to the other. And I don't know the data here, but it seems like more than half of you didn't have 4 pi radians between the 2 vertical asymptotes. I don't understand that. I don't understand. Nevertheless, I'm going to try to leave my emotion out of this and just give you the details here for this problem. That's the first thing you should do. The second thing you should do is just plug 0 in for x. You plug 0 in for x, what do you get? Tangent of 0 times 3. What's the tangent of 0? You should know that. Tangent of 0 is 0. 0 times 3 is 0. So when you plug x equals 0 in, you get 0 for y. That's why it goes through 0, 0. And then for tangent, if you go half of a period out to the right, half of a period out to the left, you've got one full period. And so where's the cosine equal to 0? That's, anyway, I think the easiest way to just plot points. And like I said, half of a period out to the right, half out to the left. We've done this plenty of times. I don't want to take the time now to do the rest of this, but look at it, understand that 2 pi is where you're going to find your first vertical asymptote. Okay? Plug in 4 pi. Start plugging in values. First time you get a value that you can't use, be 2 pi. Well, there's vertical asymptote. 2 pi divided by 4 is pi over 2. Tangent of pi over 2 does not exist. Again, it's the first angle measure or first real number that you'd replace x with that would cause this function to be undefined. And there's your first vertical asymptote. And just go to the right 4 pi radians and then get your next vertical asymptote. So, that's number 17. Again, we've talked a lot about how to graph the tangent, cotangent and tangent functions, but if you still don't know how to do that, make sure you do before the final. Number 18, you guys did a great job on that. Super happy about that. Many of you, not many of you, most of you got it right. Let's just say that. So if you got a phone call today, it's probably not because of this problem here. Some of you, though, did forget that there's a minus sign there, and instead of your graph looking like this, your graph maybe went up first and then down like that. Okay, but most of you got the period was 2. That was awesome. You put a 2 there, you put a 1 there. I didn't even make you put a 1/2 or a 3/2 there, but if you did that, great. And you went down to the amplitude of 2. So you're down to -2 here and up to +2 there. But the granddaddy problem was this guy here, number 19. Okay, this had a lot in it, and consider yourself one of the few that got it exactly right. Not very many people got full credit on this one. 3 times the secant of 2x plus pi over 4. You should have immediately factored out that 2, and in parentheses you should have x plus pi over 8. Okay, and so you gotta, first thing you would do is graph the cosine. 3 times the cosine of 2x. That's the first thing you should do. And 3 times the cosine of 2x. It should be pretty easy for you. And then you should draw the secant from that. And from there, you just move the graph of the secant, 3 times the secant of 2x, to the left, pi over 8 radians. Most of you were at pi over 4, and that was a mistake. Okay, so the origin, 3 times the secant of 2x, should have gone through 0, 3, okay, and gone up. But 0, 3 becomes negative pi over 8, 3, okay, when you move that 0, 3 to the left, pi over 8 radians. And so here's the solution. There's not a lot of explanation that needs to go into this because you've got it all before. But you need to be able to put it all together, and I hope this helps. If it doesn't help, what I'd like you to do is keep doing the problem over and over again until you can get it right. Graph 3, my advice is, step 1, graph 3 cosine 2x. Okay? Act as if this plus pi over 4 is not here. Okay? And then, after you graph 3 times the cosine of 2x, you use the cosine as kind of like your model. It's kind of like your guidelines of where you're supposed to draw the graph of the secant. But 3 times the secant of 2x just connects with the cosine. You know, where the cosine is going down, the secant is going up, and vice versa. And so you know the shape of the graph. Most of you got the shape right. You just didn't shift it to the left the correct number of radians. I don't know where the pi over 4 came from. Oh, I know why. Because that's pi over 4. You didn't factor out the 2 to make that a pi over 8 right there. Okay, so hopefully that helps. My plan is to be in school on Tuesday to help out even further. But anyway, there you have it. I will talk to you later.